Welcome to this webinar. My name is Francisco Ferreira, and I'm the president of ZERO and a professor at the Nova School of Science and Technology of the New University of Lisbon in Portugal. Today, I will be discussing with you the fundamentals of climate change on behalf of the environmental NGO ZERO as a part of the teacher training program in climate change education, an intellectual output of the Erasmus Students in Climate Change project. This webinar is part of a series of 3 modules and is designed to supplement the face-to-face training, workshop, and MOOC within the same IO4. These are the partners within the Students in Climate Action Erasmus project. The main topics of our webinar will be understanding climate change, the consequences of climate change, what can be done to reduce emissions, and are we going to change? First, let's talk about understanding climate change. Indeed, we need to understand what is changing exactly when we speak of climate change. No better way to do it than to first know what exactly is the climate. A good way to exemplify it is to differentiate weather and climate. Weather is the day-to-day state of the atmosphere, and it's a short-term variation that ranges from minutes to weeks. Simply put, it is the information that the weather people provide us every morning: humidity, wind, temperature, and so on. The climate, however, is a long-term account of the weather patterns, usually on a longer period of a minimum of 30 years. In other words, it is the information on weather patterns that allow you to know what to expect from seasonal weather throughout the year and know which type of clothes to keep in your closet to face the weather in each season. Now, to focus our attention on where all of this takes place, the atmosphere. And the atmosphere is a complex and layered space that revolves around planet Earth, composed of several gases that are fundamental to guarantee a livable planet and where, amongst other, meteorological phenomenon takes place. A lot happens in the atmosphere, and the most important regarding climate change is the greenhouse effect. The greenhouse effect is a natural process that prevents us from freezing here on the planet. Without it, the temperature on the surface of the Earth would be minus 18 degrees Celsius. This effect is like the workings of a greenhouse, hence the name. Solar radiation passes through the atmosphere and is absorbed by the Earth's surface, which re-emits the radiation at a lower wavelength in the form of infrared radiation. This infrared radiation is thermal radiation, that is, it causes an increase in temperature. This radiation is emitted by the Earth's surface into space, but it is captured by certain gases present in the atmosphere, which have the ability to absorb and re-emit it in all directions, including back to Earth. Thus, a layer with constant thermal radiation is formed, which does not immediately escape from the Earth, heating its atmosphere. This is exactly what happens in a greenhouse, where light passes through the glass, hits the ground, which heats up and radiates back from the infrared radiation, which is retained by the glass, heating the interior of the greenhouse. Greenhouse gases are responsible for heating of the atmosphere and the surface of the Earth. Carbon dioxide, CO2, is probably the most familiar since it is the more well-known. However, it is not the only greenhouse gas. The Kyoto Protocol groups the following gases in the category of greenhouse gases: the natural, and by natural we mean the ones that exist naturally in the atmosphere and come from natural or anthropogenic environments like carbon dioxide, methane, and nitrous oxide. And we can also identify synthetic greenhouse gases created by us, like the fluorinated gases, the hydrofluorocarbons, the perfluorocarbons, and the sulfur hexafluoride. Greenhouse gases come from a wide array of sources. Carbon dioxide is the most prevalent in the atmosphere and comes mostly from the burning of fossil fuels in transportation and industrial processes, as well as from forests and other land uses. Methane is generated by waste, but mostly from agriculture and livestock activities, as it is the case of nitrous oxide, which mostly comes from the use of fertilizers. Fluorinated gases are mostly generated in the industry, processes, and refrigeration, like the ones present in our air conditioners or fridges at home. Here you can have an example of the many sources of human-caused global warming pollution, from agriculture practices, forest burning, transportation, and many other factors. But the main source and cause of the rising global temperatures we are seeing today is indeed the burning of fossil fuels. Variations of the concentration of CO2 in the atmosphere is a cyclical occurrence and are expected as it has happened throughout the millennia. These variations coincide with the Earth's glacial periods and warmer periods. But what we register today is an unprecedented, record-breaking concentration of CO2 in the atmosphere. And you can see that we have an almost vertical line in the last years. Here is the evolution of carbon dioxide emissions from 1990. And as you can see, except for certain specific events, the amount of emissions have been continuously increasing. We can talk about sources of CO2, like burning fossil fuels, and the fact that we cut a lot of forests, and therefore, instead of keeping that carbon in the forest, that carbon actually goes to the atmosphere. But we also have sinks, and sinks are the atmosphere itself, the forest, and the oceans. But the problem is that the balance is positive for the atmosphere. So we have a 3% budget imbalance. Throughout the years, we can actually see what has been happening in terms of the so-called carbon global budget and the difference between sources and sinks. By looking at the global surface temperature, we can actually calculate the average from the time when thermometers started to be used worldwide around 1880 and recent years. And by looking at the difference with that average, we see that around or from 1880 to 1980, basically we were most of the years below that anomaly. But since 1980, we have been experiencing a positive anomaly with an increased temperature trend that is quite visible in this graph. Twenty of the 21 hottest years on record have occurred since the year 2002. And the hottest of all have been the last 8 years. Here you can see throughout the different years how temperature has been increasing, but with different trends in different areas of the world. So mostly we have an increase in the northern hemisphere and particularly close to the North Pole. Also, we have a decrease in temperature, for instance, in the Atlantic Ocean due to the melting of the glacier. What are the consequences of climate change? More heat waves, precipitation changes, more droughts, fires, and more intense tornadoes and hurricanes. And here we have the consequences. This graph basically shows you that throughout the years, the amount of storms, floods and mudslides, and the extreme temperatures, droughts and fires have been increasing. And sometimes we have hit many records in different countries, like the ones here in Portugal, where we in 2018 got peak temperatures in several places throughout the country. Or in Canada, where we had the deadliest weather in record history, where more than 600 persons perished in June 2021. Or like with the extreme droughts in São Paulo state in Brazil. Also, there is a clear relationship between the wildfires and the temperature recorded. As you can see, the higher the temperature, the higher the area burned. It's not only in the United States, but also in Australia, we had tremendous fatalities and areas burned due to the highest temperatures in July 2020. A lot of the heat content that we have now in the atmosphere has been absorbed by the oceans up to a depth of more than 2,000 meters. Of course, most of this effect is in the first 300 meters, and fortunately, the ocean has been saving us, because the atmosphere would be much, much warmer if the ocean that is suffering would not take this heat. Half of this increase actually occurred in less than 20 years. Let's now look at the hydrological cycle. This is how it works. Evaporation, precipitation, and then the water returns to the sea. But if in some areas we have extra heat that evaporates more water from the ocean, causing big downpours and floods, in other cases, we actually have longer and deeper droughts. Let's look at some examples. The Hurricane Florence in 2018 that affected several areas in the United States. in 2017, Hurricane Irma that made landfall in Cuba and damaged considerable areas with flooding. Or also the same hurricane in St. Martin, Caribbean, where 95% of the island was destroyed. Or the downpours that we can have under several areas in the world. More recently, the floods in Pakistan in 2022, the most severe in the history of the country. And of course, glaciers that are receding. We can compare the area of the Arctic, and you can see that it's much lower in 2016, but also the ice age in 2016 is much lower. The white areas means older ice, and that decreased substantially in 2016. And here you have the same glacier in a photo that shows that what was ice now is water. And this is a graph with the declining ice mass in Greenland. Of course, with warmer temperatures, the volume of the ocean increases. So we have a thermal expansion, and also the melting glaciers also promote that sea level rise. Therefore, we have examples of cities that might disappear by 2100 if we do not change the trend of climate change. Also, tropical diseases are a significant problem for our health because due to the climate changing conditions, they are spreading everywhere, from the equator to the poles. And we have ocean acidification, the problem of higher carbon dioxide concentrations in the atmosphere is that CO2 is then transformed into a decreased pH, an increased acidity of the ocean throughout the years. And that affects, of course, a considerable part of organisms living in the ocean, particularly the ones with shells that deteriorate within a more acidic environment. But biodiversity loss is, of course, one of the main issues related with climate change. Indeed, climate change is a threat to human well-being and the health of the planet. And therefore, without the levels of biodiversity that we have in several parts of the world, it will be quite difficult for the humanity to survive. Depending on the increase of temperature, we have different pathways where we might have considerable different impacts. But we already are experiencing what we call climate tipping points that range from the Arctic sea ice that is melting to the permafrost, where we actually have a transformation of the area in terms of the ecosystem and the type of soil, and we are emitting methane due to the warming of those areas. The coral reefs that are very sensitive to temperature variation. And of course, the deterioration of the Amazon rainforest, the Atlantic circulation as examples. So what can be done to reduce emissions? Mostly, we should look at renewable energy sources instead of burning fossil fuels. Solar, hydroelectric, biomass, wind, oceans, and geothermal. This should be combined also with a more efficient use of energy. Let's look at the global wind energy capacity. It's incredible how it is fully exponential since around 1995 and still increasing. The solar energy was supposed to grow 1 gigawatt per year by 2010. But the reality is just quite amazing. The goal was exceeded by 17 times. And in 2021, it was exceeded by 182 times. Let's look at the world's solar installations. Indeed, renewable electricity production is now much less expensive than other forms of electricity production, and therefore it should be the pathway for us to proceed. Globally, wind could supply worldwide electricity consumption 40 times over. And enough solar energy reaches Earth every hour to fill all the world's energy needs for a full year. Also, we need to preserve and also restore our forests. It is quite important not to destroy them, as it has been happening in the Amazon rainforest. It is a stock of carbon and a way for us to actually produce oxygen and continue to remove carbon dioxide from the atmosphere. Also, in terms of biodiversity, it is critical for the planet. Are we going to change? Internationally, the world starts now to call on carbon neutrality targets. Carbon neutrality is when we have a zero emissions balance, when the emissions of greenhouse gases by human activities like energy, industry, transport, and waste are the same as the removals, particularly by the forests and the agriculture soil. And we have a lot of countries with targets. The European Union by 2050, but also individual countries or states everywhere, like California in the United States or Chile. Let's look at, for instance, the examples of China, which is 2060, or even the example of Bhutan, that already is currently carbon negative. But looking at climate change, we should also consider that we have to have an equilibrium of our ecological footprint, looking at the biocapacity of each country and the type of food that we use, and a substantial difference in the way we use the different transport modes. Technology is important, but also behavioral change is crucial. So we do need a new economic paradigm of consumption, valuing biological resources, look at the material and metal recovery cluster, introducing new technological innovation, but we also should consider a governance model of locally based energy resources. And we should respect the planetary boundaries where areas are already being surpassed. So it's not only climate change, but it's also a look at the different crises that we have in terms of resources, climate, and biodiversity. We only have one planet, and it is our opportunity to actually work together, both individually and at the regional and national and international levels, to keep our climate safe. Thank you.